right, how's everybody doing? Wow, it's dark out there, bright up here. All right, here we go. My name's Zach, as Tim mentioned. I'm Zach Lead on Twitter, zachlead.com. You can read all of my blog posts about web fonts. I think there's 45 of them right now. And my title for today is Anvil Transition Enthusiast, so look forward to a lot of Anvil transitions. We're going to enjoy those together. The title of my talk today is The 5 Whys of Web Font Loading Performance. You know, I was advised not to include a carousel in my title slide. I ignored that advice. So we have a nice sliding transition there for you all. Carousels are amazing. All right, so how many people, let's see a show of hands, how many people are familiar with the 5 Whys technique of user research? Yes, okay. Wow, about 10. Okay, that's great. All right, so the 5 Whys technique just basically involves asking a user, as they're using your software, why 5 times repeatedly to try and find the root cause analysis of what the problem is that they're having. And it's also used by my 3-year-old when she wants more candy. Isn't that right? Well, you can kind of forget about this technique because we're not actually going to go over the 5 Whys technique at all. Today we're going to look at the 5 Whys technique for web font loading. So why is a glyph in a font file, and we're going to load 5 different Whys. Bait and switch, here we go. So today we're going to kind of do a live case study of the default WordPress theme when you go to WordPress.com and create a new blog. It's just a very simple, static page for a blog website. And the theme that they have associated with this is actually a pretty lightweight website. It's not too big. It's only 595 kilobyte. Not too bad, 35 requests, and it's actually comprised of 17% web fonts in, amazingly enough, 5 different requests, 5 different web font files, about 100 kilobyte of web fonts. And so today we're going to kind of have 5 players. Number 1, in the red, sans serif weighing in at 15.3 kilobyte. In the yellow, sans serif bold at, again, 15.3 kilobyte. We have serif, 22.9 kilobyte. Ooh, it's a little bit, serif fonts, they got more to them. You got to pay more. Serif italic, 20.8 kilobyte. And serif bold, weighing in finally at 26.2 kilobyte. So all the demos that I'm going to go through today are hosted on GitHub. The demos can be live viewed on Netlify. I've hosted them all on Netlify just for web page testing. And you can go to that repo, and I'll show this link at the end as well, and I'll put the slides on Twitter. So the methodology I've used for these tests, I'm using web page test to run all of our tests on the 3G network speed. They're using HTTPS and HTTP2 because they're hosted on Netlify. You get that for free on Netlify. And they're running in Chrome, which means that we're going to be using the WAF2 format, which includes a little bit better compression than the WAF format. And for this case study today, we're only going to be doing font optimizations. It was very tempting for me to want to go in and improve some of the other loading optimizations for the theme, namely the CSS loading strategy was really not that great, but today we're going to focus solely on web font loading. And I think that will give us a nice pragmatic view of how to improve our web font loading without sort of taking an idealist approach. All right, so this is what it looks like when it loads. A nice white screen. Everybody loves white screens, right? Yeah, it's great. 3.3 seconds later on 3G connection, you get first render. It looks like this. All the text is invisible. Steve kind of mentioned this morning on the New York Times site that first render happened on the New York Times, and then the web fonts sort of caused the text to become invisible later, which was unfortunate. And then at 5.7 seconds, you get visually complete. All the text is readable, and all our web fonts have successfully loaded. And we get a nice color-coded waterfall. Oh, how nice is this visualization? If you are not able to distinguish these colors, the order is consistent throughout the slides. So we'll always have serif on top, sans serif, serif bold, serif italic, and then sans serif at the bottom. So when it comes to improving web font loading, there's kind of two big enemies or opponents that we have that we're trying to fight against. The first one is invisible text. We absolutely despise invisible text. It's horrible for the perceived performance of our page. We want to render our text to the user as quickly and efficiently as possible. A lot of times people will call this a flash invisible text or FOIT. We don't need to sort of use those jargony terms. They're kind of going away, but I just want to mention that some people call that FOIT. In 2015, this man, Mitt Romney, was running for president, and he was deciding whether he was going to run for president. And Slate ran an article announcing his decision, whether or not he was going to run for the US president. And James Musprat captured this screenshot on his iPhone, and the title on Slate.com says, Mitt Romney is running for president. All right, congratulations to him. I'm sure it will go well. But in fact, the problem is that he was not running for president. And the issue here was that the bold web font had loaded, and the italic font was still waiting to load. It was invisible. And this kind of means something completely different, doesn't it? Very unfortunate. So invisible text can cause a lot of weird race conditions that we don't really want to our users to encounter as they're loading our pages. So not great. The other thing that web fonts are famously known for is text in motion, moving text. The user's reading the page, they're halfway through the article, the web font finishes loading, and everything reflows. It's a very bad experience, so I'll kind of talk about strategies that we can mitigate that as well. And a lot of people will actually put these two different opponents into two different camps. So which do you like better? Do you like invisible text, or do you like unstyled text, which is called fout, flash of unstyled text, which I'm told in Dutch means bad, which I guess is something I also agree with. But these two camps aren't really necessarily diametrically opposed from each other. I think both of these things are bad. So we don't want invisible text, and we don't want unstyled text. We want to get our web fonts rendering as quickly as possible so we have neither of these problems. So, man, a lot of anvils there. Got any anvil fans out there? No? All right, one. Great. This is boding quite well for my anvil-laden presentation. All right, so we have a lot of performance metrics that we measure, and a lot of these are not good when it comes to measuring web font performance. When you get first render, first contentful paint, there's actually no content on the page. There's an image, I guess, which is why the browser thinks that it's contentful, but it's not actually useful for the user that wants to read what's happening on our blog. So not great. So what we want to measure is first meaningful paint. It's finally a metric that properly accounts for web fonts. It includes a built-in delay so that it waits for your web fonts to finish, or your web font to finish, when your biggest layout happens. And you can measure this using Lighthouse. What I like to measure, and this isn't really available in any tools that I'm aware of, is when all text is visible and readable to the user. So when it comes to our default WordPress site, the default experience, all text is visible about 4.9 seconds, so about 1.5 seconds after first render. Not great. And we'll talk about how to improve that. And the other metric I'm going to focus on today is web font reflow count. So how many web fonts return and re-render and reflow after our first render happens? So this is our text in motion problem that we're talking about. So if you look at the page in Microsoft Edge, you bring it up, so Edge and IE, by default, have visible text while web fonts are loading, which is great, because you don't need to use font display or any other sort of fancier loading strategies to get visible text. And we'll just kind of go through it. So the first reflow is when the sans serif bold returns. The second is up in the top right corner, sans serif. Serif bold loads there. Serif comes in, 4 reflows for web fonts. This is great. We have a rogue reflow that's not actually associated with any web font finishing. It's got to be a bug in Edge. I'm sure I'll file that after this presentation. And then finally, the serif italic finishes and re-renders our block quote there. So not a great experience when it comes to loading web fonts. And so potentially every web font that comes back, even if the text isn't invisible, you get a reflow associated with that. So your text can move 5 times while you're reading an article. Not great. So these are the 2 things that we're kind of going to be measuring today and focusing on today as we go through how to improve the default web font loading for our WordPress theme. All right, so before we sort of get into web font loading, a lot of times I have discussions, very healthy discussions, about why don't we just use system fonts? Why don't we use web-safe fonts? I really like the term web-safe, as Robin Rendell calls it. He sort of coined that term, system fonts or web-safe fonts. And I think that really harkens back to the days when we used to worry about web-safe colors. So I really like that framing that he's used. So how does our page load when we remove all the web fonts? So we stick with just our fallback, which is serif in this case. And it's really not, I mean, it's better, but it really doesn't affect our first render all that much. We do get 200 milliseconds, which is nothing to sneeze at. It's great. That's 200 millisecond improvement. Visually complete improves by 10%. That's great. Amazing. But the important thing here is that system fonts don't do any network requests. They have instant rendering. You get visible text on first render, which is great, right? All right, so thank you, everybody. I'm all done for the day. Oh, sorry. Let's get serious now. Let's do a crayon analogy. Got my 3-year-old in the audience. She loves crayons. Come on. So you got a 24-pack of crayons. This is our system fonts. You can express way more emotions, right, with 120 crayons. Amazing. More is better. Let's get a little bit more diversity. It's awesome. So maybe you're the person that busts out the acoustic guitar at the house party, thinks that it's the most amazing thing to play acoustic guitar in front of other people. But might I suggest to you that perhaps an orchestra might allow you a greater range of emotion? And I'm going to get salty. I'm going to get salty right now. It's going to be good. Here we go. Maybe you think that presenting your users with the best viewed in Chrome modal is something that's good. But I think the Chrome developers would also agree that it's better for the web in general if we invest our testing resources in cross-browser testing and boost the value of the web as a whole. But whatever the case, use of web fonts is increasing. We can't really fight it. Maybe you don't have control over your design, and your designer has requested you use web fonts. So let's go with it. So again, we're coming back to our default WordPress site, and it's using Google Fonts. Google Fonts is a great free CDN for web fonts. It's very easy to use. You can just dump a link block right on your page, use it in your CSS. And I don't want today's talk to sort of have the tone that I'm picking on Google Fonts, because I think it's a great tool, and it's really sort of offered web fonts to a lot of people that wouldn't have otherwise included them on their pages. So let's give them credit for that. But as we've kind of heard today, self-hosting can really help the performance of our pages. So today we're going to go through 9 different tools in the next 31 minutes and 45 seconds and show how these will change the loading profile of our default WordPress theme. And when I say 9, I mean 7, because really our Google Fonts files are already WAF 2, so we already got that for free, and they're already subset to the Latin character set. So we're not going to really talk about subsetting too much today. If you want to learn more about that, you can hit me up later, or go to my website and read about it. And that could be a completely separate talk that we could completely focus on subsetting. One of the things the theme authors did add, which is great, is they use Preconnect for their Google Fonts. So they added this link rel Preconnect that sort of set up the connection for the actual font files themselves, so we can get those initial connections set up out of the way. And this is what the source code looks like in the header. They use DNS prefetch, which is, in my test, didn't really help all that much. But Preconnect is really the great thing that sort of allowed the connection to Google Fonts, the Google Fonts CDN, to be set up ahead of time. And importantly, there was a couple of link tags, a couple script tags, an inline style, and a style sheet before the Google Fonts CSS request was sent out. And that is a blocking request. Not great. But we're not going to focus too much on how to make that asynchronous because we're going to delete all of the Google fonts later. All right, so with and without Preconnect, this is what the loading profiles look like. The top request there is the CSS, and the middle 5 requests highlighted there are the fonts. So you can see with Preconnect, all of our initial connection setup here happens much sooner. So it's a little bit quicker. It's quite nice. Preconnect browser support is pretty good. We don't really need to go over that too much because that is a progressive enhancement. We don't need to worry about that. So Preconnect, the thing that you should know about Preconnect is it's great for cross-origin font requests. It's a really, really great resource. All right, let's move on. Let's remove the Google fonts altogether and see how the loading profile changes. Move to self-hosting. All right. Should we do a drum roll? No? All right, well, let's just do it. All right, so we moved to self-hosting and improved our first render by about 6%, which notably is the exact same measurement that we got for our system fonts, which is, I guess, it was interesting to me. But the problem here, so just in terms of a legend moving forward, I'm going to keep this sort of specter of the baseline experience as sort of a shaded background here so we can compare the individual enhancements that we're making to our baseline performance profile. And all our text is readable with this nice black bar there with the eyeball emoji. Self-hosting, so much better, right? It's amazing. No, it's terrible. Look at that. It's our web fonts took much longer to load. Not great. So what happened here? When you actually look at the web page test results and the waterfall there were super long TTFBs for these requests. It should have been short, right? They were on the same origin. They weren't a cross-origin request. There was no CSS request. It wasn't a two-hop. There wasn't a two-hop request for Google Fonts like you would have. We inlined our CSS. Our font face blocks were available right there in the initial HTML payload. Could it have been network congestion? Patrick Meenan actually wrote a blog post about this, and he thinks that there's a lot of existing problems with bad HTTP prioritization. So if you look at the web page test waterfall, image requests that were medium priority, we're taking priority over our highest web font requests that we're loading. So this is not a great behavior that we have. So what can we do to work around this problem? Move to a different origin. And I'm not going to make a lot of friends by posting this slide, but I moved the fonts to a different subdomain on Netlify. How did that affect our performance? I actually shortened our font request by quite a bit. I used Preconnect here to set up the initial connection request to the new subdomain that we're hosting on Netlify to set up that cross-origin request. We kept our 3.1 second initial render. So probably don't do this. Probably don't set up your web font requests on a different origin. It did work for me. It was a tool that I tried, and it did help the performance of my page. But this sort of sharding approach, and I know it's not technically sharding because it's just a single separate domain that I'm using here, but this sharding-ish approach, I just like saying sharding. It's an anti-pattern on HTTP2. So it's not something I'd necessarily recommend that you try first, but it did actually help the web font loading of this page. And to that, I would say one person's trash or one person's anti-pattern is another person's treasure pattern. And it's just a tool that's in our toolbox that we can try out. If it doesn't work for you, that's fine. But just know that it's an option that's available to you. So we're kind of back where we started, right? The performance of our page is not that much better than than Google Fonts. So why would we self-host? What are we getting from this? We're certainly not getting any better cache hits from users that have an empty cache coming to our page where they might have downloaded Google Fonts from a different page request. And to that I say, well, just hold your horses a little bit. We're getting to the good stuff. All right, so font display is the next thing we're going to go through. Font display is a CSS descriptor you can add to your font face block. My favorite is swap. Font display swap. That shows the fallback font immediately, and it renders the web font whenever it comes back. Another popular one is font display optional, and that will render the web font only if it's cached to the end user. So usually repeat views will render the web font, and empty cache views will use your fallback font. And this is just one line of CSS you can add that's really pretty great. A couple of cautionary things I would add about font display optional. If you have a page that does Ajax navigation, so something that takes over your page's experience and doesn't really re-render a full page view, don't use font display optional because the web fonts will never load. And icon fonts. So icon fonts, this would be a terrible experience, right? Because you'll see a bunch of fallback glyphs. The fonts will they'll only be rendered if they're cached. And maybe on that note, I should just mention that you should not use icon fonts altogether because there's no existing font display descriptor property there's no existing font display descriptor value that will work properly with icon fonts. So those are kind of just outside the mainstream of what the specification has intended for them to be used as. So I would discourage you from using icon fonts and using SVG whenever possible. And so this is kind of new because font displays actually has really good wide browser support right now. We're kind of in a new world. It's kind of great. The problem here is that Edge doesn't support it, but as we mentioned earlier, IE and Edge both have a font display swap-ish behavior default built in. So it's great. No invisible text there either. And this is kind of amazing, right? Because we no longer need JavaScript to load a web font with visible fallback text. That's great. Hooray. Only CSS-only approach. Hooray. It's faster. All right, so what does this look like on our performance profile? Not much different. But, however, our little eyeball emoji that measures when our text is visible, now it's on first render. That's great. Amazing. We want to get that text as readable as quickly as possible. All right, so we've defeated the invisible text opponent. Amazing. Congratulations to us. And now we move on to the much more difficult text in motion problem. One of the tools we have to do to attempt to defeat that is use Preload. We've heard a little bit about Preload today. Maybe not font specific, but this is what it looks like. Rel Preload, you point it to your WAF2 format because all the web browsers that support WAF2 support. All the web browsers that support Preload support WAF2. You add this cross-origin attribute there, even if it's on the same domain, for reasons that we can discuss after this talk. And Preload browser support is pretty good. It's behind a flag in Firefox, so we're just kind of waiting there a little bit. But support is actually not too bad. And again, this is a progressive enhancement, so it's not going to hurt your page if the browser doesn't support it. So what does it look like when we preload all 5 of our web fonts, and how does that compare to our baseline? Actually, it's pretty good. It's not terrible. It moved up our initial font request start a little bit, not too much. But importantly, 2 web fonts finished, this red one here and the orange one here, finished before first render, which is a very important thing to take note of, because anything that finishes loading before first render will not be a reflow. You don't have to pay reflow penalties for that. So we're kind of racing between using preload, trying to get our request to finish before our first render happens. One of the other problems that we have with this is that when you add 5 web fonts to preload, we don't really have control over which ones will finish first and which ones we might be okay with finishing later. And we'll talk about how to mitigate that a little bit later. And the other problem here is that we have a bunch of wasted time here. So we did our initial connection setup here using Preconnect, but sharding is really hurting us here. It's not helping us at all. It was helping us before, but then when we try and use preload, it's not great. So when you try and preload fonts from a different origin, the cost that you pay for even if you do Preconnect really comes at a very terrible time. So let's get rid of our sharding. Let's move our fonts back to the same domain or the same origin, and let's preload all of them at once. Let's see what happens. So this is, initially you might think this is amazing because all 5 of our web fonts finished before first render, but you're paying a super high cost for this. 500 milliseconds of first render time. And that is way, way too expensive for web fonts. We want to use web fonts in a way that won't impact our first render at all. So this is kind of terrible. We have a trash can emoji indicating this 500 milliseconds of wasted time. So when you overuse preload, it will cost you in first render time. So not a great experience. So I have some really amazing keynote physics here. I'm super excited for you guys to see this. Check that out. Oh my goodness. 3 fonts preloaded. Look, did you guys see that first render go up? That was amazing. All right, so we want to preload some of them, but not all of them. But how do we choose? How do we decide? It's kind of like having a favorite child. It's a lot easier to pick when you only have one. So we're going to get a little bit subjective here, and I'll go through real quickly 2 different prioritization strategies for how do we decide what to preload and what not to preload. First one is user disruption, and the second one is metrics-based. So when it comes to user disruption, you want to look at where your web fonts are used on your page and sort of decide what your primary use case is for the page. And then ask yourself what reflows are most likely to be the most disruptive to the user as they interact with your page. So in this case, they're coming to our blog. They want to read our blog post articles because we have amazing text that we want the world to read, right? So we might pick these 3. Our serif bold, and our serif italic. So we might preload those. And that's great. What I like to do is to use the second prioritization strategy because that might not sort of extrapolate out. The user prioritization strategy might not sort of extend out to a bunch of different use cases you have on your page, and you want to use a single font loading strategy for all of them. So what I like to do, oh great, I went back, animation, here we go. What I like to do is to use metrics prioritization. So preload 1 of each family. So for this example, we have sans serif, and then the serif one. We don't want to necessarily load our bold or italic and bold versions. And when we use this prioritization strategy, it works great in Safari. And I'll explain why. And this is how it renders on the page. So not great when it comes to thinking about what the user actually wants to do on the page, but if we preload our Roman version here, in this example we're using the serif, when the Roman is available on the page, the browser sort of has a decision that they need to make when they're trying to render a bold element that exists on the page. Most browsers will render the fallback, which in this case is Times or Times New Roman, depending on your operating system. And what Safari does is they use something called font synthesis. They render the Roman version and then synthesize a sort of fake bold or faux bold version of the font on its way to the bold version. So this element, while it's loading, most browsers will show the fallback text on the left. So our Roman has successfully loaded. The yellow portion here is rendering in the full web font. And this is the fallback. So our serif fallback. But what Safari does is they use a fake faux bold version of the Roman web font. So we preloaded one web font over here in this case, but we sort of have a fake bold and a fake italic available to us. They render. And the nice thing about this is that when your full web fonts load, the metrics, the dimensions of the actual glyphs for the web font change much less. There's a lot less disruption to the end user. I'll maybe play that a couple times. So this is the fallback when our Roman is loaded. And this is the full version. I cheat a little bit just because the image moved, but that's fine. So my plea to any browser makers in the audience today, could you copy this behavior, please? Because it's amazing, and I love it. Because we didn't have to use any JavaScript, and we really got a much less disruptive path for the user to go through to render our web fonts. All right, so preload and font synthesis. Next, we're going to go over the CSS Font Loading API. But first, let's do a little mini review, because I know I've presented a lot of information here. Our opponents up front, invisible text, we eliminated that with font display, CSS descriptor. That's great, that was pretty easy. But we're trying to fight this text in motion problem. So when a web font loads, it could have a reflow. We have 5 web fonts, so 5 reflows potentially. We tried to preload everything, which was not great for our initial render time, but no reflows. So that was one benefit. And when we preload 2 fonts, it works great in Safari. We still have 3. We have 2 of our web fonts will finish loading before first render, but we still have 3 potentially disruptive reflows that happen after first render. Not great. So how do we eliminate or further mitigate those 3 different preloading, 3 different reflows that happen after our initial render? We can use the CSS Font Loading API. And so to create a web font request using this JavaScript, I did actually talk about some JavaScript today. Tim, you're welcome. You can create a font face object here. It looks very similar to font face syntax. You pass in the font family, the URL with the format. You load it. And then, most importantly, after it's loaded, after it's finished loading, you add it to the document. So when you add it to the document, that's when it renders. So the page doesn't take any rendering, doesn't do any rendering of a web font until it's finished loading. And if you want to load 2 of them together and repaint them both at the same time, or render them both at the same time, you load them both and just connect them with a promise here in the middle. And then just add them both at the same time when they've both finished loading. So you can kind of see how we could use this strategy to group all of our reflows into one single reflow that happens simultaneously. And the nice thing about this approach is that you don't have to do any CSS maintenance. A lot of times when I've talked about this before, we've added sort of a CSS class to the document that sort of, we set our font families behind this CSS guarding class, but we don't have to do any sort of CSS maintenance to do this. We can just leave our style sheets as is. So this is kind of where we're at. We self-hosted, which allowed us to use font display and preload. We're still sharding on our second stage of web font loads here. And we use the CSS Font Loading API to sort of group them all into one single reflow that happens to the user. And the super nice thing about this, that I really love, is that when it comes to the font synthesis behavior we talked about earlier, we've now normalized this to work in every browser that supports the CSS Font Loading API. So we've normalized this cross-browser. So every browser will sort of render this fake bold while the bold is loading. And then when the bold finishes, it will re-render using the full bold web font, which is great. It's less disruptive to the end user. So we have a much gentler reflow that happens, reflow that happens. Yeah, and there's only one. So amazing. And once your fonts are JavaScript controlled, which our second stage fonts were in that example, we can get a little fancy with it. We can use the Network Information API to opt out of fonts on slower connections. And Chrome does some of that automatically, but we can sort of extend that to other browsers. We can use the Save Data user preference. So when the user has enabled data saver mode, we can disable our web fonts altogether to save the user some kilobytes if they're on a pay-as-you-go data plan. And we can use prefers reduced motion to opt out of font reflows altogether. So if the user has enabled this reduced motion in their accessibility preferences, we can opt out of the second stage web fonts altogether, so the user won't see any reflows. So that is super powerful and amazing. And the last thing I want to talk about is variable fonts. So variable fonts are kind of the new thing in the web font loading world. They're the rock star, they're the up-and-comer. People love variable fonts. And I'm going to completely destroy those rose-colored glasses for you today. Here we go. So variable fonts are really amazing. They're great. And they allow you to sort of combine our 5 different web fonts using into fewer files. And then the variable font will render and gives you much more granular control over your weight, your slant, or your italic. And you can the font designer can specify in the font file which axes they want to be available to the users or to the developers of the font. So in this hypothetical situation, you might think, or you might consider that our 5 fonts could be combined into 2 variable fonts, one for the serif and one for the sans serif version. And here's an example of what a variable font might look like. And this little video is taken from Access Praxis, which is a great variable font playground. You can go out and check that out. And it really gives you super, super, super fine-grained control over your font's rendering. It really, really opens up a lot of new design possibilities. So they're really, really an amazing thing. So when we look back at our 5 individual font files, they added up to about 100 kilobyte when you think of them all added together. And this one compressive version that was on Access Praxis that was used in this video here is about 100 kilobyte by itself. So the font files can be much larger. So what I've done is I did not take Compressa because I don't have licensing access to that. I used a 115 kilobyte variable font, source sans variable, and I added it to this page to sort of get an idea of what a single serial request for a variable font might look like as opposed to our 5 individual file requests that might have happened before. So variable fonts will really affect your loading profile, maybe not in the way that you might want. It really extended that our web font visibility to the end of that elongated waterfall bar there. So just keep that in mind when you're using variable fonts. They can be bigger. But one of the great things about variable fonts is that you get a single reflow. You don't have to use JavaScript to combine your reflows into one. You're using a single file. So there's only one reflow associated with that. So I went out to v-fonts.com, which is another variable fonts playground site, just to kind of get an idea of what the file sizes of variable fonts looked like. And you can see a nice bar chart here. So they really went up to about 250 kilobyte was the biggest one. And the average was about 69 kilobyte with a median of 54.1. So they're not quite as bad as I suggested with my 115 kilobyte example. Just keep that file size in mind when you're using variable fonts moving forward. All right, wow, okay. We made it through 9 different strategies, 9 different tools in our toolbox for improving our web font loading. And this is kind of where we ended. Let's just go through this one more time so we can kind of drive it home. We used font display. Well, let's just go through it one at a time. So we got WAF2 and subsetting for free from Google Fonts. I downloaded those files, moved them to self-hosting. So that was great. We want to make our files as small as possible. We moved to self-hosting so we could use Preload and font display. That was important for us. We used the CSS Font Loading API to sort of combine all of our reflows into one. Our font files actually finished loading about 750 milliseconds faster than our initial fallback request. And we've mitigated most of our text in motion problem. We don't really have any unstyled text that's shown to the user because we're using this font synthesis approach to have a more gradual reflow or more gentle reflow to display to the user. And so, yes, all the demos that were shown today are available on GitHub. If you want to check out my website, I wrote a comprehensive guide to font loading strategy. It's no longer comprehensive because it's 2 years old. I'm going to update it. There'll be a version 2 coming. But I do have 45 and counting font loading blog posts on my website. I maintain web font loading recipes, which shows individual strategies and how the code you can use to implement those, and you can put those on your pages and test them out. And I just want to take just a few seconds of your guys' time to thank these people. They sort of inspired me. Tim sort of alluded to the fact that I was obsessed with web fonts, and a lot of that obsession is sort of inherited from me following these people on Twitter. So I'll put these slides online. Definitely follow these people. They're amazing. Thank you.
Thanks, Zach. Just watch out. There's an anvil at some point. I'm not sure where in the stage, but it's going to drop.
All right.
Yeah. So there was quite a few questions, I think, that came out around some of the stuff with the font synthesis.
Okay.
So one of them is, could you kind of elaborate then on the difference between loading the regular font file and a bold font file versus loading the regular and then having like font weight or whatever to try and define the bold and enhance it? Like, what happens there? Why are you pulling in 2 files?
Yeah, so when a browser uses font synthesis, a lot of the actual rendering of the web font it looks very synthetic, so it will appear much lighter than the full bold version might. So it's more about just minimizing the amount of change that you see between your Roman and your full bold that loads. So it gives you a little bit of a transition strategy between those 2 stages. If you only load the single web font file for Roman, it will try and make that fake one and just keep it forever. And the only thing that we want font synthesis to do is to be shown for a short period of time until our full bold version has loaded. We don't want to necessarily use that as our final end goal. We just want to use it as a transition strategy.
Sure. Okay, that makes sense. And then from when you add the font loading API on top of that, right, you're tapping in that JavaScript, and that sort of normalizes the synthesis behavior. There's nothing, what about that process kind of brings the other browsers into that sort of WebKit-based
Right, so before the web fonts have loaded, before we've added them to our document using the CSS Font Loading API, the browser has no knowledge of them in terms of our CSS rendering. So we control when the web fonts render. You could render them at any point. You could render them not at all. And so to the browser, it only knows that we've preloaded the Roman version, so our sans serif or our serif version, and it has those available. So it thinks that our end goal is a font synthesis version of those nodes. But really, we're sort of holding all of our cards up to our chest and saying that we have all these web fonts that are coming in later that we're going to render at a much later time.
So you're kind of hiding it from the browser, which tricks it into that sort of synthesis.
Right, we're hiding it behind JavaScript.
Makes sense. Cool. So that was a lot of different stuff, kind of like piggybacking, that is not a word, piggybacking on top of each other. And we've had a lot of random advice and strategies for how to approach web font loading in the past.
Yeah.
And 2 of the things that I think were really prominent were this sort of idea of trying to use local storage for, using this, or even just the more hardcore, like, embed your font face inside of a media query so that it's not loading on a mobile device kind of a thing, right? And you're using your web fonts only on larger screens or whatever. Does this do you feel like those sorts of things are no longer necessary? You don't really ever have to do those sorts of things now with all the new APIs and standards we have?
Yeah, so if you go out to read the web font loading strategies, comprehensive web font loading strategies blog post I wrote, there is an article or a subsection of that about using data URIs and local storage to sort of render web fonts, and that is an anti-pattern. And I recommend that no matter what you try, just measure it. Go to web page test and run some A/B tests and see what comes back. And I think that you will really find that using data URIs for web fonts is an anti-pattern, and I've sort of discouraged people from doing that. But the other thing that you mentioned sort of with media queries and sort of hiding web fonts from mobile devices, I think that makes a bad assumption about network reliability being better on a desktop device. So there's a lot of weird assumptions that go into people sort of bifurcating their mobile and desktop experiences. And I think that we should try and match those up as much as possible so we don't really make those bad assumptions for the user.
Right. So something like the Network Information API makes a ton more sense for that kind of a decision to be made.
Yeah. Yep.
Cool. Awesome. Thank you, sir.
Thanks.